One of the most important systems on the airplane, besides the airframe itself, is the engine systems. And you saw the walk around, you had a look at the engines, and they are V2500 engines. Airbus 320 comes with an alternative choice. You can have the V2500 or you have the CFM56. Before we look at the engine instrumentation on ECAM, it might be an idea just to show you what a jet engine is made of. This is a typical modern high bypass engine with a big front fan, much smaller compressor section behind that front fan. This is the burner section, this is the turbine section, and then the hot gas from the combustion process moves rearwards. This part of the engine is the duct, the bypass ducting, which contains a lot of just cold air accelerated by the front fan, which mixes at the back end of the engine here to reduce the sound, making these engines very quiet and, by the design here, very efficient. At the top screen, first of all, we've got the three analog digital presentations. The engine pressure ratio, EPR, is a measure of power of the engine. It looks at the pressure at the front of the engine and the pressure at the back of the engine. Exhaust gas temperature, this is picked up in the jet pipe, measured in degrees centigrade. Certainly provide you a cup of tea very quickly, that would. 415 degrees centigrade. The rotor speeds, the big fan at the front is referred to as the N1, and it's running at 83.4%, 5% now of its design speed on the left engine. These instruments, of course, the same on the right engine. And then the N2, which is the high pressure compressor inside the casing of the engine, which you can't see, running at 87% of its design maximum RPM. Maximum RPM on this engine is a state secret, but somewhere around 14,000. On the right of the engine warning display ECAM, we have CL, meaning climb thrust, and that is the climb thrust rating, 1.45 EPA. The fuel flow in kilos per hour, left engine 1240, right engine 1180. And some general information here, that's fuel on board 7,720 kilos. The lower symbol here indicates that the flaps are up, and we use that only on takeoff and landing. The lower ECAM screen, conveniently headed engine, contains a lot of information about less important functions. The fuel used, again split left engine number 1 engine, right engine number 2 engine, and for the vibration also. Fuel used, the oil quantity measured in quarts, the oil pressure within the engine, unusually high for those of you more familiar with car engines perhaps. This is running at 194 pounds per square inch. The oil temperature, 125 degrees centigrade. And then the cell temperature, which is a free air temperature inside the engine, the cell above the engine itself, running 160, 165. The vibration indicators, we've got one on each rotor. The N1, that's the big fan at the front, the N2, the high pressure rotor, and vibration well down, 0.6, 1.3. We don't get alarmed until it gets up to somewhere like 3. The bottom of this screen, again some useful stuff. Temperatures here, this is the total air temperature, and this is the static air temperature. The difference between the two is the effect that the airplane movement is having, friction. So outside it's minus 52 degrees Celsius, but because we're moving through the air rather quickly, something more than 500 miles an hour, it's warming up a bit, and the actual aircraft skin is only 26 degrees centigrade. A quick sum shows you there that the kinetic effect of the aircraft movement is something like 27 degrees. UTC, the clock, and there's the weight of the airplane, which is worked out from the information we put in the FMGS before we take off.